All right, students, welcome to the Sigma classes. So today we are going to continue a topic, whatever we learned yesterday, we are going to further extend it. So let's get started with the first topic. Or first of all, let's try to recall whatever we discussed yesterday. So yesterday we discussed about the three cases where the two lines can intersect. The first case was intersecting lines. Let me make that table again. Intersecting lines, then we had the coincident lines, and finally we had parallel lines. now, now the thing is that for intersecting lines, there will be only one common solution. This is what we have discussed yesterday. Those who haven't watched that video, kindly go through that video first and then watch this video. Coincident case where we had infinitely many solutions. And in case of parallel lines, we had no solution. Okay. And the algebraic conditions were, in case of intersecting lines, a1 upon a2 does not equals to b1 upon b2. For coincident lines, the algebraic condition is a1 upon a2 equals to b1 upon b2 equals to c1 upon c2. And finally, for parallel lines, a1 upon a2 equals b1 upon b2, but doesn't equals to c1 upon c2. So these are the algebraic conditions. And these conditions are really important because we are going to solve some really interesting questions that were already asked in the board examinations. So let's get started with the first question. So first question we have is, here we go. The first question says that, and this is from the CBSE 2019 questions. Find the value of k. Find value of k for the following pair of linear equations. 2x plus 3y equals to 7. And then we have the second equation, k plus 1x plus 2k minus 1 into y equals 4k plus 12. Now, students, we need to solve this question. We need to solve for the value of k. So let's get started how we can solve. It's so easy. You all can see the value of k. Yes, it's anyway, let's get started. So what I was saying, they have the infinite many solutions. It is given that the pair of linear equation in two variables has infinitely many solutions. Today, one student has joined our session, and I am really happy to see his messages. Anyways, let's continue with the question. So if we compare it with the standard form, we all know the standard form is a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0. So now you will get to see a1 is equals to 2, b1 equals to 3. If you are just comparing with the standard form, you how to compare it? How to convert this equation in the standard form? See, we want to make the right hand side as 0. 7 को उधर लेके जाओ, ये -7 हो जाएगा. तो b1 we got 3 and c1 will be -7. a2 will be what? A2 is the coefficient of x in the second equation. It's going to be k plus 1. b2 is the coefficient of y, so it's going to be 2k minus 1. And finally, we have c2 is the thing, but minus 4k plus 1. Because if you take this 4k plus 1 on the left hand side, it would be negative. Okay. Yeah. Imagination is really like, what do we call it? It's invaluable thing. Like support is if someone can imagine that. Anyway, so let's get started. Why I'm saying that let's get started. Let's continue. So for infinitely many solutions, the condition is, a1 upon a2 equals b1 upon b2 equals c1 upon c2. Okay, so now what to do? You just need to put the values of a1, a2, b1, b2, and c1, c2 in this condition to get the answer. All right. So now a1 is what? A1 is 2. A1 is 2, A2 is k plus 1, B1 is 3, B2 is 2k minus 1, and C1 is minus 7, and C2 is minus 4k plus 1. Okay, so minus will get cancelled out. So now, how to solve for A? It's so how to solve for K? It's so easy. Just take any two ratios and try to solve them first. So we have 2 upon K plus 1 equals 3 upon 2K minus 1. Do the cross multiplication. 2 into 2K minus 1. So what you will get? 2 into 2K, 4K. 2 into minus 1, minus 2. Now, K plus 1 into 3, it's going to be 3K plus 3. We all know how to do the calculation. 3k on left hand side and minus 2 on the right hand side. So it's 4k minus 3k, it will be k. 3 plus 2 will be 5. So we got the value of k as 5. You can take any two of the ratios in order to solve for k. Okay, I hope this is clear to all of you. So k will be 5. That's how you will be solving for this. Okay, let's do another question. Yeah, I know how to calculate. Let's do another question. So we have this question. The question says, this question was asked in CBSE 2023 exam. Okay, so the question says, again, it's for infinitely many solutions. So the question is, let me write down the equations. 2x plus 3y equal 7, and 2ax plus a plus bi equals 28. So we need to solve for the values of a and b, and the system has infinitely many solutions. All right. So again, students, for infinitely many solution, the condition we all know. The condition is a1 upon a2 equals b1 upon b2 equals c1 upon c2. Let me get the values of a1, a2, b1, b2, and c1, c2. So easy. A1 will be what? A1 is going to be the coefficient of x. So 2 divided by A2 is the coefficient of x in the second equation, 2a, which is equals to B1. B1 is the coefficient of y in the first equation. So 3 divided by B2 is what? B2 is the coefficient of y in the second equation. And C1, it's again, you have to convert these equation in the standard form first. So you have to take the 7 on the left hand side, it will become -7, and this 28 again on the left hand side, so it will become -7. So you all know the negative sign will get cancelled out. So 7 upon 28, eventually it's nothing but 1 upon 4. Now we need to solve. Now we need to solve for A and B. So in order to solve for A, see, if I just take these two ratios, I won't be able to solve. Why? Because there are two variables involved here. So I cannot get the value of one variable from. So now what to do? I'll be taking this ratio and this ratio because they all are equals to each other. So 2 upon 2a equals 1 upon 4. So from here, 2 will get cancelled out. So eventually we are going to have 1 upon a equals 1 upon 4. So from here, do the cross multiplication. A, you got 4. You got the value of a as 4. Now let's find out the value of b. 3 upon a plus b equals 1 upon 4. So now we need to solve. We need to solve for b from here. So I already got a value of a. So let me put down the value of a here. That's 4 plus b equals 1 upon 4. Do the cross multiplications. What we are going to get? 4 plus b into 1. So we are going to get 4. Now 4 into 3 is going to be 12. So from here, b is going to be 12 minus 4. That is nothing but 8. So we got the value of a and b as 4 and 8. एक्चुअल में मैंने आज शाम थोड़ा ठंडा ठंडा करने का जूस पी लिया, तो इसीलिए शायद खांसी हो रही है और लस्सी भी पी ली. So this is the thing. Anyway, let's try to solve another question. So we have another question, and that is from the NCERT example. By example, के question किया करो. Best questions of the example. Okay. So now let's do another question. The question says that two straight paths are represented by represented by the equations x minus 3y equals 2 and minus 2x plus 6y equals 5. Check whether the path cross each other or not. Check whether the path cross each other or not. Let's understand this question. Straight. The opposite of straight is what? Rangeen. Anyway, uh, two straight paths. देखिए, दो सीधी सीधी सड़कें हैं. पहली सड़क ये वाली इक्वेशन शो कर देती है, दूसरी सड़क ये वाली इक्वेशन शो कर देती है. ना हमें बताना है कि यार दोनों पाथ आपस में क्रॉस करेंगे या नहीं. क्रॉस करने का मतलब क्या है कि इंटरसेक्टिंग होंगे या नहीं. अगर वो इंटरसेक्टिंग हो गए तो इंटरसेक्टिंग के लिए जो कंडीशन है a1/a2 does not equals to b1/b2 ये सेटिस्फाई होनी चाहिए. अगर ये सेटिस्फाई हो रही है तो हाँ, ओके. अगर ये सेटिस्फाई हो रही है तो हाँ, अदरवाइज दे विल नॉट क्रॉस ईच अदर. सो व्हाट आई एम गोइंग टू डू, मैं इन दोनों को कैसे सॉल्व करूंगा. देखो दो तरीके हैं हमारे पास. वी कैन सॉल्व देम बाय ग्राफिकली हम ग्राफ पर रिप्रेजेंट करके कर सकते हैं, बट इट विल कंज्यूम अ लॉट ऑफ टाइम. It will take a lot of time. First of all, you have to find at least two solutions for both the equation, and then you have to prove the graph. It will take a lot of time, and it won't be a good idea, or it won't be a good approach to solve such type of questions. We can easily solve them. See, that's why we made the algebraic method. Now, that's why we made the algebraic method in order to solve such type of questions. So instead of plotting them on the graph, I'm going to compare their coefficients. If the condition of any case gets satisfied, so that will be the case whether the paths will be intersecting each other, or they are coinciding each other, or they are never going to meet each other. So what I'm going to do, x minus 3y equals 2. Let's convert this equation in the general form. X minus 3y minus 2 equals to 0. Second equation we have 2x plus 6y equals 5. Oh, it's minus 2x. It's minus 2x plus 6y equals. So it's going to be minus 2x plus 6y equals minus 5. Minus 5 equals 0. I'm going to take this 5 on the left hand side now, so it will be minus 5 equals 0. So now let's compare it with the standard form, and we are going to get a1 as 1, b1 as minus 3, and c1 as minus 2. Now a2 is what? Minus 2, b2 is 6, and the c2 is minus 5. So let's compare the coefficients. I'm going to find out the value of a1 upon a2. It's going to be 1 upon minus 2, so it's nothing but minus half. Let's find out b1 upon b2. b1 upon b2 is nothing but minus 3 upon 6. Again, it's minus half. Let's find out c1 upon c2. The c1 upon c2 is what? Minus 2 upon minus 5, which is nothing but 2 upon. So do you see something here? Do you see something here? Key, the condition is what we got. The relation is a1 upon a2 equals to b1 upon b2, which is does not equals to c1 upon c2. So this is the condition for parallel lines. This is the condition for parallel lines. And we all know that parallel lines never meet each other. So therefore, these two paths are never going to cross each other. These two paths will look like this. Parallel है ना, कभी आपस में touch ही नहीं करेंगे. Okay? These two paths are never going to touch each other. So the road will not cross each other. That will be the final answer. Yeah. Anyway, let's do the last question of today. Let's do one more question. Want to do a question for let's say intersecting lines. Intersecting lines के लिए कोई मिल जाएगा. Okay, so here we go. Here we go. No, I'm not going anywhere. This is the last question I said, and I'll be continuing tomorrow as well. So I'm not going anywhere. You don't need to worry about it. For which value of lambda do the pair of linear equation lambda x plus y equals lambda square and x plus lambda y equals 1 have a unique solution? See, we get a unique solution only in the case of intersecting lines. So we are going to use the condition for intersecting lines. Anyway, so now we have to solve for the value of lambda. So let's see how we can see. It's a unique solution. It's a unique solution. So it means it's a case of intersecting lines. And the algebraic conditions for intersecting lines is a1 upon a2 does not equals to b1 upon b2. So what I'm going to do, I'm going to find out the value of a1, a2, b1, b2. So let's compare with the standard form. A1 should be lambda. A2 should be A2 should be 1. B1 should be 1 and B2 should be lambda again. All right. So now, yeah, it's unique actually. It's a unique solution. So now I'm going to put down the values here. Lambda upon 1 does not equals to 1 upon lambda. Now, how to solve such type of equation? This is an inequality, not equality. So we are going to solve this equation by using the same concept as they did for equation. So do the cross multiplication, lambda into lambda will give you lambda square. Do the cross multiplication, lambda square equals 1 into 1, that's 1. Now we have to solve for the value of lambda. So lambda from here is going to be minus plus minus 1. So it means the value of lambda can be any real number, but not plus minus 1. क्यों? क्योंकि अगर प्लस माइनस 1 हो गया तो a1 अपॉन a2 इक्वल्स टू b1 अपॉन b2 हो जाएगा। अगर हमने सपोज यहाँ पर मैं पहले आपको रख के दिखा देता हूँ। देखो मैं क्या कर रहा हूँ, मैं लैम्डा की वैल्यू 1 लेके तो यहाँ पर भी 1 रखूंगा और यहाँ पर भी 1 अपॉन 1 1 अपॉन 1। तो ये तो दोनों इक्वल हो गए और कंडीशन क्या है कि ये इक्वल नहीं होने चाहिए, तो इसीलिए लैम्डा को हम प्लस 1 तो नहीं रख सकते। ये समझ में आया होगा आपको? ठीक है, ऐसे में माइनस 1 रख के देखता हूँ। लैम्डा अपॉन 1 यानी माइनस 1 अपॉन 1 डज नॉट इक्वल्स टू 1 अपॉन माइनस 1। तो ये भी सेम है, माइनस 1 ही है, तो हम लैम्डा को माइनस 1 भी नहीं रख सकते। ठीक है, हम लैम्डा को माइनस 1 भी नहीं रख सकते, क्योंकि अगर ऐसा होगा तो a1 अपॉन b2 इक्वल हो जाएंगे b1 अपॉन b2 एंड this is not the condition for unique solution. The condition for unique solution is that a1 upon a2 should never equals to b1। ये कभी आपस में इक्वल नहीं चाहिए। तो ऑब्वियस सी बात है, अगर हम लैम्डा को प्लस 1 या माइनस 1 रखते हैं तो ये इक्वल हो जाएंगे। तो लैम्डा विल हैव दिस इज द साइन ऑफ बिलोंग्स टू, इसको हम बताते हैं बिलोंग्स टू। ठीक है, लैम्डा बिलोंग्स टू रियल नंबर्स। लैम्डा की जगह आप कोई भी रियल नंबर रख लो, एक्सेप्ट दिस विल बी द सॉल्यूशन। जो फाइनल लिखा हुआ है ना लैम्डा की क्या वैल्यू रखनी चाहिए, आप ये सॉल्यूशन लिख के आओगे कि लैम्डा बिलोंग्स टू रियल नंबर एक्सेप्ट प्लस माइनस, ये आपको फाइनल लिख के आना होगा, यही इसका सॉल्यूशन। Okay, that's why I was looking for a intersecting line question, because these questions are really good. And I hope this is clear to all of you. Now, if you still have any doubts, see the comment section is open for all. Whatever you want to ask, you can write there. And please provide your valuable feedback. And if you like my content, please do subscribe to our channel. It will help me a lot. Now I'm going to end the session.